Hello students, how are you? I hope this tutorial finds you very well. Today I just brought one final examination of Applied Mathematics 1. So within this final exam there are a lot of different questions. So I'm going to show you how you can solve all these questions here properly. So as usual, your subscription and giving comments as well as your likes are highly required. So directly going to the final exam. As you see, this final exam has two parts. Part 1 has 20 short answer questions and part 2 has 5 different workout questions. So I'm now going to show you how all these questions can be done. Let me show you the content of this final exam. As you see, there are 20 short answer questions, and from these 20 short answer questions, 8 are available as you see here. And next from these, questions from 9 to 14 are labeled. And here, questions from 50 to 20 are also included here. So I'm going to show you how all these fill in the blank questions are going to be done in this tutorial. Next from this, there is part 2, and which is actually workout problem. And here there are 5 different questions, and from these 5, 3 of them are written here as you see, and the rest 2 are as can be shown here. So make yourself ready. I'm now going to show you how you see every question here is going to be done. So here is the first question from part 1. So here you are given two vectors, vector v and vector w, and you have been told that they are orthogonal. Remember students, if two vectors are orthogonal, then the dot product of the two must come to be 0, because if you remember, the dot product of vector v and w is the product of their magnitudes times cosine of the angle between the two. And if you are told that the two vectors are orthogonal, you do have 90 degrees in between. So cosine of 90, as you know, is 0. Because of this, the dot product must make what? 0. And it is due to this concept that we can do this question. So the solution goes like this. Here is the concept I told you. So let you take these two vectors v and w as you see. Here I took dot product between the two. So your vector v is a vector with component x21, and your vector w is a vector with components 1, 0, minus 1. So as you are performing dot product between the two, x times 1 is x, 2 times 0 is 0, and 1 times minus 1 is minus 1. So this equation must be equated with 0. As you see, look, x times 1 is x, 2 times 0 is 0, 1 times minus 1 is minus 1 equals 0. And this makes x minus 1 0, students. This makes x minus 1 0. And from this, what follows is x is equal to 1, right? From this, x equals 1 is going to come, okay? So it is when x is 1 that the two vectors are going to be orthogonal. So next from this, we have question number 2. And question number 2 says, suppose you are given a vector v with components 1, 1, 0, and w radical 2, 2, and radical 3. So you are asked to find the projection of vector v on w. Remember students, we have derived a certain formula on projection of vector a on b. If you remember, we said that the projection of vector a on b is a dot b divided by the norm of b squared times b. Similarly, now using v in place of a, w in place of b, we can determine the projection of vector v on w as follows. So the solution runs as you see. The projection of v on w is v dot w over norm of w squared times w. So as you see, v dot w is nothing but it is 1, 1, 0 dot with radical 2 to radical 3, because the component of v is 1, 1, 0 and the component of w is radical 2 to radical 3. So in doing this dot product, 1 times radical 2 is radical 2, 1 times 2 is 2, whereas 0 times radical 3 is 0. So you are left with radical 2 plus 2. Now we need to determine what the norm of w is. The norm of w, in fact, is the square root of the sum of the square of the components. But since this is squared, we don't need to use the radical expression. So you simply square the components, radical 2 squared plus 2 squared plus radical 3 squared. So this basically is 2 plus 4 plus 3. And finally, you are going to have 9. So everything is now obtained. V dot W is already determined. Norm of W square is already determined. So it's a matter of now plugging these obtained values in your equation or expression. So this is going to be finally 2 plus radical 2 over 9 times W, where V dot W is 2 plus radical 2 and norm of W square is 9. So you simply take W radical 2, 2 radical 3 here in place of W, and you finally have this expression as you see. And up next is question number 3. And question number 3 says the following one, okay? You are given a certain vector V having components A, 1, radical 2. And the x-axis is given. So what has been given here is the angle between vector V and the x-axis is 60 degrees. So having this into account, you are asked to determine what A is going to be. So in order to determine this, what you have to do is the following one, students. Look, take a unit vector along the x-axis. If you take a certain unit vector along the x-axis, V dot I is going to be this one. We know by definition that the dot product of two vectors is the product of their norms times cosine of the angle between the two. So the norm of V is going to be what, students? A squared plus 1 squared plus radical to the whole squared and radical times the norm of I is 1, students, and that is 1 times cosine 60. You know that cosine 60 is 1 over 2, right? So this is going to be 1 over 2 radical 3 plus a squared, because radical 2 square is 2, 2 plus 1 is 3. And of course 60 is 1 over 2, so you are going to have 1 over 2 radical 3 plus a squared. And here we are having V dot I, you see, vector A1 radical 2 dot with 1 0 0, because there is also another option where you can write the dot product of these two by using, you see, this approach. So we knew the components of vector V, A1 radical 2, they are all written here, and the I is a unit vector along the x direction, so its component will be 1 0 0. So as you are performing this dot product, A times 1 makes what? A. 1 times 0 is 0, radical 2 times 0 is 0. So you are going to have the following one. So it will be A. Now we are having two identical expressions, V dot I, but two different expressions. So necessarily the two must be the same. And from this you can equate these two, and then you can have this expression 1 over 2 into 3 plus a square equals A. So multiplying the whole by 2 to avoid this fraction, radical 3 plus a square equals to A can come. Now squaring both sides, what can come is 4a squared 3 plus a squared. Now move this a squared to the left, it's going to be 3a squared equals 3. So dividing both sides by 3, you will have a squared to be 1. So the possible values of a can be either positive 1 or minus 1. So you do have two options for a. This is how you can determine a, right? Now what comes next from this is question number 4, and here in question number 4 we are having a vector V with component I minus j plus k and vector W with minus I plus 2j. You have been told that the two vectors are orthogonal to both V and you are asked to find two vectors which can be orthogonal to both V and W. As you know, students, the cross product of two vectors is nothing but it is orthogonal to what? The two vectors V and W. So we are directly going to obtain what V cross W is going to be. So the vectors V cross W and W cross V must be calculated because both can be orthogonal to what? These two. Even though one is the negative of the other, the two can be orthogonal to both V and W. So we are expected to calculate now these two, okay? So we knew that V cross W is the same as negative of W cross V. So let's determine one of these two and multiple by negative to determine the other. V cross W can be obtained by using this approach, ijk. We must have the components ijk here. So now let's write components of V. Here they are 1, minus 1, and 1. So they are written here. And components of W follow minus 1 plus minus 1, 2, and 0 because the key component is not written, so it's understood 0. So have plus minus plus, and The I component is obtained by deleting the first column in the first row. In this case, -1 times 0 is 0, minus 2 times 1 is -2. So you are going to have 0 minus 2. This is I, sorry, image, please correct it. And then the j component is going to come, as you see, is obtained by deleting the first row and the second column without forgetting taking minus into account. And 1 times 0 is 0, minus -1 times 1 is -1, negative negative makes +1. J and the k component is obtained by deleting the first row and the third column, which actually we will consider positive one here, positive number here. So 1 times 2 is 2, and minus -1 times -1 makes +1, so -1 can come. So finally, this is going to be 0 minus 2 is -2. It is corrected here. It's -2i minus j plus k. So dear students, the vector v cross w, which is given by -2i minus j plus k, is basically orthogonal to both v and w. How do you assure that? Just carry out dot product between the obtained expression and these two. You will obtain that to be 0, students. And since we wrote here saying that v cross w is the negative of w cross v, now finding w cross v is so simple. So to find w cross v, what you need to do is you have to take the negative of what you obtain here, v cross w. So in doing so, you can have minus of the obtained expression here, -2i minus j plus k. So multiplying the whole by negative, you do have 2i plus j minus k. So again, dear students, you can assure that this is also orthogonal to both v and w. So the two possible orthogonal vectors for vector v and w are, as you see, -2i minus j plus k and 2i plus j minus k. I hope it's understood. Now, what follows from this is question number 5. You have been told that, you see, a point is given, 0, 0, 0, and this point is lying on the plane, and another line is given to you here, and the line has been told here that it is perpendicular to the plane. So in order to answer this, what you have to know or understand is this one. The directing vector of the line. You see, student, this is the directing vector of the line. The line is parallel to the directing vector, and the directing vector is the vector with components 1, 2, minus 3. So if the vector is parallel to the line, and if the line is perpendicular to the plane, necessarily the vector 1, 2, minus 3 is perpendicular to the plane. So you can consider this vector as the normal vector to the plane. So using that, we can determine the equation of the plane. So here, what you need to do is the normal vector here is a vector having components a, b, c, which is identical to 1, 2, minus 3, because this is basically a directing vector to determine the line. So this directing vector is parallel to the line. Since the line is parallel to since the line is perpendicular to the plane, what happens to the directing vector? The directing vector is going to be again perpendicular to the plane. That's why I'm just considering this vector as the orthogonal vector or the normal vector to the plane. So my ABC are 1, 2, and minus 3, and you have been told that one point on the plane is the origin, x0, y0, z0. You may take the origin as you see. Now remember the formula. We have determined, or we have derived the formula. Equation of a plane like this: a into x minus x0 plus b into y minus y0 plus c into z minus z0, where a, b, c are components of the orthogonal or the normal vector. x0, y0, z0 are coordinates for a point lying on the plane. So using this direct substitution, you see in place of a, b, c, take 1, 2, minus 3, and here in place of x0, y0, z0, you see take the origin 0, 0, 0. So you are going to have 1 into x minus 0 plus 2 y minus 0 minus 3 z minus 0. So simplifying this makes 1 times x, 2y minus 3z equals 0. Therefore, students, the equation of the plane is going to be x plus 2y minus 3z is equal to 0. I hope you have understood it. Okay, students, now proceeding to the next one. Question number 6. You are asked to find the rank of this matrix. A matrix is given, a 3 by 3 matrix, so you are supposed to look for the rank of this one. So as you studied in the classroom, the rank of a matrix is nothing but it is the number of non-zero rows in a given matrix. So we're now going to apply echelon form in order to determine the rank of this one. Okay, so what we need to do is the following. So let us apply row operations on this matrix A to determine the rank of the matrix. So you are given with this matrix. So what I'm going to do is I'm going to change row 3. The row 3 is going to be changed as you see, multiplying row 1 by -2 and adding with row 3, and in doing so this can come. What I did here is this one, -2 times row 1. Look, if you multiply this by -2, let you multiply all entries in the first row by -2 and add with row what? 3. So -2 times 1 is -2, plus 2 makes 0, as you see. And -2 times -2 is -4, so -4 plus -1 makes -5. And here -2 or -2 times -1 is +10, and +10 plus -10 is -8. So take the rest, the first and the second rows as they are, you see. Now we are having this. Look, we are getting closer to row echelon form, but we do have some additional thing to do. And that is this one. Look, again, let's change row 3, the third row, in the following way, just multiplying row 2 by 5 and adding with row 3. So look here, if you multiply the row 2 by 5, and add with R3, what happens to R3 is the following one. Look, 5 times 0, it is 0, and 0 plus 0 is 0. 5 times 1 is 5, 5 with -5 is 0. 5 times 2 is 10, and 10 plus -8 is 2. So we are having this. Now look, this is actually row echelon form, so it's already reduced to row echelon form. So now count number of non-zero rows from this. This is a non-zero row. Again, this is non-zero row again. And if you see the last row again, it's non-zero. So the rank of this matrix is going to be 3 because the number of non-zero rows after we change the given matrix to row echelon form, as you see, is 3. Therefore, as you see, the rank of this one is 3. And what comes next is question number 7, students. In question number 7, you are given this matrix, and then you are asked to determine these two. The first is to find the determinant of this 4 by 4 matrix, and the second is about to know what can be said about this inverse of this matrix. So to answer this, what you need to do is you need to recall properties of determinant, right? So if you remember, students, property of determinant said this. Look, the second row and the fourth row are identical. So if you are able to obtain identical rows within a matrix, then clearly without any sort of ambiguity, the determinant comes 0. So you need to recall that. So for A it's done, the determinant is going to be 0. And if the determinant is 0, as you all know, you have been discussing that if the determinant is 0, we are unable to obtain the inverse of the matrix. So the matrix is said to be what? Non-invertible, and we call it a singular matrix. So the answer for the second is going to be a singular matrix or a non-invertible matrix. And what comes next is question number 8, and in the case of question number 8, you are given this. Determinant of the square matrix is 3. Then you are asked to find the determinant of the square of this expression. So again, you need to recall these determinant properties. So using that, I can show you how this can be obtained. So the solution goes like this. First, you have to note some important points. The determinant of A is the same as the determinant of the transpose of the matrix, and the determinant of an identity matrix is 1. Next, determinant of product of two matrices is the product of the determinants, because I'm going to apply this into account here in this calculation. Now, the determinant of A times A transpose times A inverse the whole squared can be written in terms of this, because as I said, these can be squared, but determinant of, you see, two different matrices or identical matrices can be, you see, written as the product of these two determinants, as you see. So applying this one, I can write it this way. Now let's just find one of these two, because the two are identical. So if we are able to determine one of these two, it's a matter of squaring it. So let's now find determinant of one of these two. So the determinant of A times A transpose times A is a power of -1, which actually the inverse is determinant of A times determinant of A transpose times determinant of A inverse. And this is, you see, before we determine this, we need to know this one. A times A inverse makes identity. You see, that's the meaning of inverse. A given matrix is the inverse of another one if the product makes an identity, right? So A times A inverse is identity, so applying D to both sides, determinant of A inverse is the same as determinant of A times determinant of A inverse. Students, I'm applying this here, don't forget. So this has to be the same as determinant of I. And from this, we can have determinant of A inverse to be determinant of I divided by determinant of A. What I did here is I just brought this one, you see, to this side. And we know that determinant of identity matrix is 1, as I said earlier, and determinant of A is 3, because it's already given for you here. So the determinant of A inverse is already obtained, so everything is now obtained, so we can plug everything here. Thus, the determinant of A times A transpose times A is a power of -1, which actually the inverse is determinant of A times determinant of A transpose times determinant of A inverse. And determinant of A is 3, and here determinant of A transpose is the same as determinant of A, and here 3 comes again. And for this, we obtain that to be 1/3, so 3 times 3, 9, 9 times 1/3 is going to be 3. Thus, students, what has been obtained here is, you see, 3. But this is repeated as you see here, so 3 times 3 is going to come, which actually is 9, right? I hope you have understood. What comes next is question number 9. In the case of question number 9, you have been given systems of linear equations, as you see. For this system to have a unique solution, you are asked to determine what A is going to be. So basically, dear students, what you need to do is the following one. First, you have to determine the main determinant of these coefficients. So write the coefficients of x1, x2, and x3 in terms of matrix form, and later in terms of determinant form. So the coefficient of x1 are 3a3, so they are labeled here as you see. The coefficient of x2 are -1, 4, and -1, -1, 4, -1 as you see. The coefficient of x3 are 2, 5, 3 as you see. This must be different from 0 in order to have a unique solution, because here you see, if you remember, in order to know what x1 is, we have been using dx1 over d. So the main determinant, this must be different from 0 to have a unique solution, you see. Because we are having here 0, 0, so as you are looking for x1, dx1 is going to come to be 0, okay? So 0 divided by, you see, a certain number can be 0 except 0. That's why we are making the main determinant, this one, to be different from 0. Now, just applying first row expansion, just find the determinant of this one. So positive 3 is taken, then delete this column and this first row. Then 4, 5 minus 1, 3 can come. This makes 12 plus 5 as you see. And here -1 is going to come, and here minus is going to come. So it will be +1. Remember, student, that as you are taking first row expansion, this is kept to be plus and this is minus, but minus makes plus as you see. And here plus, positive 2 is taken. So when you delete, you see the second column in the first row, A533 can remain as you see. And coming to the last one, as you delete the third column in the first row, A43 minus 1 can come. So this result must be different from 0 in order to have a unique solution. And from this can be obtained, guys. 4 times 3 is 12, minus 5 times -1 is -5, minus makes +5. You do the same for these two, and then you will obtain this expression as you see. Now simplifying this, what comes here is this one, 51 plus 3a minus 15 minus 2a minus 24, different from 0. And from this, a plus 12 comes to be different from 0. So finally, you will obtain a to be different from -12. So the value of a here can be any real number except -12. So here it is. Having this into account, what comes next is question number 10. In the case of this, you are given a matrix A as you see. Now you are asked to find the characteristic polynomial of A and the eigenvalues of A. So students, in order to answer this, what you need to do first is you have to find, see, the characteristic polynomial. And the characteristic polynomial is determined by just looking for a determinant of A minus lambda I, where lambda is a real number. It is regarded as eigenvalue. And I is an identity matrix. Since the given matrix is 3 by 3, we're going to consider I to be a 3 by 3 sized identity matrix. So once we obtain A minus lambda I, we need to determine, you see, the determinant, and that makes nothing but it is a characteristic polynomial. So what comes here is this one, like determinant of A minus lambda I is going to be determinant of, this is nothing but it is A, I directly copied and pasted here, minus lambda comes here, and what I is, this is identity 1, so we are having this. So we need to multiply this by lambda, it will be lambda, lambda, lambda here, the rest are going to be 0. So when you take the difference of the two, you are going to have this expression, okay? 1 minus lambda 1, 2, 0, 5 minus lambda minus 1, 0, 0, 7 minus lambda. So finding the determinant of this is nothing but it is finding characteristic the polynomial. So here, look students, how many zeros do you have? Just try to identify a row or a column having so many zeros. If you see the last row, it is a row with 2 zeros. So let's expand, you see, this by using third row in order to determine determinant, because it makes our calculation simple. So in doing so, we can obtain this one. Look here, students. Here, plus, minus, plus is going to be considered. So when you take positive 7 minus lambda, you do have 7 minus lambda. Then try to, what? Cover the third row and the third column, because 7 minus lambda is located at the intersection of third row and third column. So what comes here is the determinant of 1 minus lambda 0, 1, 5 minus lambda. So I was applying this one, 1 minus lambda times 5 minus lambda is going to come, and 1 times 0 is 0, so you are going to have this expression alone. So you may consider it as your characteristic polynomial, or if you want, you can multiply or simplify. You will finally obtain this to be, as you see, minus lambda cube plus 13 lambda squared minus 47 lambda plus 35. I obtain this simply multiplying the upper expression. You see, these three binomials. So students, this is an expression as you see, and we call it polynomial because as you see, it's a polynomial expression. So this is called the characteristic polynomial of the given square matrix. It is from this that we can obtain the eigenvalues, right? So if you equate this to be 0 and look for, you see, the values of this lambda, you are going to obtain eigenvalues, right? So the characteristic polynomial of A is, as you see, this one. Now, if you want to know what the eigenvalue for this, you do have determinant of A minus lambda equals 0. And from this, look, this has been equated with 0. So it's a matter of looking for the zeros of this expression. But already, the zeros of this expression is nothing but it's the zeros of, you see, the upper expressions because the two are identical. So determinant of A minus lambda I is already done. Here it is. That has been equated with 0. So you are having this. And from this, you are having this one, 7 minus lambda, 1 minus lambda, 5 minus lambda equals 0. So from this directly, we can know what lambda is going to be. Either lambda has to be 7 or 1 or 5, right? So the eigenvalues of A are 7, 1, and 5. Dear students, you may be also asked to determine the eigenvectors corresponding to each lambda. In this case, what you need to do is you have to apply, you see, another approach, and that is obtained by just having a certain vector, let's say x, and then using the approach ax is equal to lambda x. So for each lambda, we can have different vectors corresponding to eigenvectors for lambda. Okay, using this approach, you can determine the eigenvectors that you've been asked. Okay, I hope you have understood. Okay, dear students, what comes next is question number 11. It's about limit equations. Limit expressions, limit questions. So in question 12 again, we do have limit questions. So I'm going to show you how this can be done one by one. So simple. So the solution runs like this. The first one is to find the limit of x squared minus 2x plus 1 as x approaching to minus 1. Dear students, in the case of limit calculation, if you are able to use direct substitution without any problem, I strongly advise you to use direct substitution, okay? So put minus 1 in place of x throughout, so minus 1 squared is 1, and here plus 2 comes plus 1. So this is 1 plus 2 plus 1, which actually is 4. Done. And when you come to b, it says limit of absolute value of x plus 2 over x plus 2 as x approaching to minus 2 from the left. So remember, student, that the absolute value of a number is greater than or equal to, you see, 0 if the number is positive. I mean, the absolute value of a number is the number itself. If you are considering, you see, the number inside the absolute value is greater than or equal to 0, and it will be negative if it is obtained to be what, less than 0, right? So the absolute value of x plus 2 is x plus 2 itself if x is greater than or equal to minus 2, because x plus 2 is greater than 0 when x is greater than or equal to minus 2. But you see, here you have been told to find the limit of this function as x approaching to minus 2 from the left. So you need to consider, you see, numbers less than minus 2, okay? Numbers, I mean, yeah, numbers to the left of minus 2, right? To the left of minus 2, you're going to consider that. So the absolute value of x plus 2 in this case is the negative of x plus 2, right? Because the absolute value of x plus 2 is the negative of x plus 2 for x plus 2 less than or equal to 0. So shifting these two to the right, it's going to be x less than 2, less than minus 2. So as you are using different values less than minus 2, this absolute value of x plus 2 turns to be the negative of x plus 2. Now you're having x plus 2 as a denominator here. We can cancel x plus 2 by x plus 2, and we are left with minus 1, right? A constant number is going to come. So the limit of a constant number, no matter x getting closer to a certain number, it will be minus 1. So this is going to be minus 1. And going to question number 12, we are having this limit x squared minus 1 over x plus 1 as x going to infinity. So let's multiply this by 1 over x. Again, this one 1 over x, so that you see the analysis can be simple. So as you are multiplying this by 1 over x, x squared divided by x comes to be x, and this is 1 over x. And this is 1 because I'm dividing or multiplying this by 1 over x. So this turns to be 1, and 1 over x goes here. So as x is turning to infinity, look, this is approaching to 0. Again, this is approaching to 0, so it will be meaningful. But as x goes to infinity, look here, x again here is going to infinity. So the function in general goes to infinity. That is the idea, okay? And coming to b, we are having the limit of x sine 1 over x as x going to infinity. So here, in order to find this one, what we need to do is, let's use y to be 1 over x, students. If you assign this to be y, look, as x goes to infinity, 1 over large number approaches to 0. So as x goes to infinity, y approaches to 0. So if y is 1 over x, your x is going to be 1 over y. So now let's change this one directly to this form. This limit comes as it is, but as x goes to infinity, it turns to be y approaching to 0. Because as x goes to infinity, by our assumption, y is getting closer to 0. And here, sine, directly use that. But here it says 1 over x. So we know what 1 over x is, it's y, right? So y. And here we are having x, and we know what x is 1 over y. So multiplying sine y by 1 over y makes sine y over y. From the two important limits we discussed in the classroom, this is nothing but it is 1. So this is number 1. Now what comes next is question number 13. Question number 13 says that find the limit of these two expressions. The first one is limit of 1 plus 3x power of 1 over x as x approaching to 0. The second, as you see, is ln of x plus 2 over x plus 1 as x approaching to minus 1. So to do this, what you need to do is the following one. Okay, so let y to be 1 plus 3x the power of 1 over x. So now introduce ln both sides. So this will be ln y is equal to, now look, when you introduce ln, 1 over x comes down. And ln of 1 plus 3x over x can come. Remember logarithm property. If you are using ln here, the one that has been taken as exponent comes in front. And it will be 1 over x ln of this, and this actually this one. Now, dear students, let's look for the limit of this ln y. The limit of ln y as x goes to 0 is going to be the limit of, we know what ln y is from this expression, ln of 1 plus 3x over x as x going to 0, approaching to 0, I mean. This is actually infinity, 0 over 0 indeterminate type of limit, because as you put 0 here, it will be 1, ln 1 is 0, this is 0, so it is a 0 over 0 type of indeterminate limit, so we can directly apply L'Hopital's rule. Simply we derive the numerator and the denominator directly, okay? So in doing so, we can obtain this one. Look, what is the derivative of ln of 1 plus 3x? We know that the derivative of ln is 1 over x, but in x we are having 1 plus 3x, so 1 over 1 plus 3x comes. But the inner function again needs to be derivated, so as you are derivating the inner one, it will be 3. And we know the derivative of x is 1, so we are having this limit of 3 over 1 plus 3x as x approaching to 0. Am I able to substitute? Yes, nothing hinders me not to do so. So from this directly 3 can come, because when x is 0, 3 over 1, 3 comes. This is not the answer. What we obtain here is the limit of ln y, not y, right? Our intention is to know what the limit of this is, or y is as x approaching to 0. So the limit of the question we are going to answer is equivalent to the limit of y as x approaching to 0, because by assumption we said that this is y. But we knew that y can be written as e to the power of ln y. And from this is going to be e to the power of limit as x approaching to 0 of ln y. So this is going to be e to the power of 3, because the limit of ln y as x approaching to 0 is already obtained. It is obtained to be 3. So e to the power of 3 can come. Done. Simple, right? Now comes b, students. In the case of b, we are having limit of ln of x plus 2 over x plus 1 as x approaching to minus 1. We know that as x approaches to minus 1, this is going to be ln of, if you substitute, it will be 0. Ln 1 is going to come. And here again, minus 1 plus 1 is 0. So a 0 over 0 indeterminate type of limit is going to come. So for such type of, you see, limit analysis, you need to apply L'Hopital's rule, application of derivative, in fact. So this is going to be the limit as x approaching to minus 1 of, let's now find the derivative of ln of x plus 2. So the derivative of ln of x plus 2 is 1 over x plus 2. And here the inner one is x plus 2, so its derivative is 1. And again, when you derive x plus 1, it is 1. So no need of worry about that. So we are left with this. Am I able to use minus 1 here directly in place of x? Yes. It gives meaning, no problem. So 1 over minus 1 plus 2, which actually is 1 over 1, 1 can come. This is how it is done. I hope you will get this simple. And coming to the next question number 14, what comes is, you see, what comes here is the concept of continuity. You have been given a certain piecewise function, as you see, which is defined as 0 and which is not defined as 0. Then in order for this function f to be continuous at 0, you are asked to determine what a is going to be. So recording the definition of continuity, students, if f must be continuous at 0, then necessarily the limit of f of x as x approaches 0 must be the same as f at 0, continuity, right? So here what we need to do is the following. The limit of f of x as x approaching to 0 is nothing, but it is limit as x approaching to 0 of which of these two shall you consider? The upper one, right? Because x is approaching to 0. X is not 0. If x is approaching to 0, you are using different numbers, different from 0 into account. So in that case, you are using different numbers different from 0, so your function is going to be the upper one. That's why I took radical x plus 1 minus 1 over x for your function f of x. So this must be equal with f of 0. We know that, student, f at 0 is nothing, but it is a, because f at any x is, you see this one, if x is different from 0, but if x is 0, as it has been said, it is a. So we'll equate this with a later, okay? But we need to determine the limit of this one, because this has to exist. Now, from this, what I'm going to do is, you see, you have to look for the limit of this one, and for this, L'Hopital's rule can be applied, because if you put 0 here, it will be 1 minus 1, 0 over 0, indeterminate type of limit. So when you derive this one, it will be 1 over 2 radical x plus 1, right? And the derivative of this is 0, and the derivative of this is 1. So you are left with 1 over 2 radical x plus 1. So am I able to use 0 in place of x? Possible. So put 0 there. It will be 1 over 2, right? So 1 over 2 can come. So they said this limit has been obtained to be 1 over 2, and this has to be the same with f of 0, but f of 0 is already what? Named to be a, so this is a, so the value of a is now obtained to be 1 over 2. I hope so simple. What comes next is question number 15, students. Question number 15 says, if you are given these functions, you are asked to find their derivatives. The first one is to find the first derivative and second derivative. The second one is to find the first derivative at any x and at specific number 1. So this is so simple, so let's directly go to the solution. So this is your f of x, which is ln of cosine hyperbolic of 2x. So we need to apply a chain rule for this. So the derivative of this is going to be like this. We know that ln of x, derivative of ln of x is 1 over x. So you are going to have 1 over cosine hyperbolic of 2x. And then you need to derive the inner one cos hyperbolic of 2x, and for that you're having sine hyperbolic of 2x times 2, because again in cosine hyperbolic 2x we have inner function 2x that has to be derived, so 2 comes out. So this is nothing but it is the first derivative of, okay, the first derivative of f, right? The first derivative of f at any x value. Again, you are asked to find the second derivative. The second derivative of this is nothing but it is obtained by using quotient rule. Just derive what has been derived here. So according to quotient rule, we need to derive the upper one. So the derivative of the upper one will be 2 times cosine hyperbolic of 2x times 2, and that 2 times 2 makes 4, then 4 times cos hyperbolic of 2x times cos hyperbolic of 2x as a multiplier is going to be used. Then minus is taken into account using quotient rule. Then take 2 sine hyperbolic 2x as it is already taken here, you see. And then we need to multiply by its derivative, the denominator's expression derivative. So the derivative of cos hyperbolic 2x is sine hyperbolic 2x, right? And then 2 is going to come out, and we were having 2 before here. 2 times 2 makes 4. So we are having now this expression. Look, the denominator must be squared using quotient rule. Now everything is obtained. The next task is a matter of simplifying this. So this is, look, 4 has been written twice, so we can take it out as a common. So cos hyperbolic squared 2x minus sine hyperbolic squared 2x can come. And this needs to be squared. Now look, using this property, cosine hyperbolic property and sine hyperbolic property, cos hyperbolic squared 2x minus sine hyperbolic squared 2x makes 1, right? So 1 times 4 makes 4, so you do have 4 over cos hyperbolic squared 2x. Basically, dear students, 1 over cos hyperbolic squared 2x is sec squared, right? Sec hyperbolic squared 2x, so you are having now 4 times sec hyperbolic squared 2x. So finally, the second derivative of f at x is obtained as you see. And coming to b, you see, coming to b, you are given a function f of x tan inverse x squared. So we need to find the derivative of this one. We know that the derivative of tan inverse x is 1 over 1 plus x squared. But here in x squared, we are using x squared. So x squared squared turns to be x to the power of 4. But the inner function, again, x squared must be what? Derivated, as you know. So the derivative of, see, tan inverse is 1 over 1 plus x squared, but in x, we do have x squared. So x squared squared makes x to the power of 4, and again, need to derive x squared comes to be 2x. So 1 times 2x is 2x, and this is 1 plus x to the power of 4. That is it. But again, you are asked to evaluate 1 in place of x, students. Look, it has been asked here in Roman number 2 under b. So we need to substitute 1 in place of x. So as you are substituting 1 in place of x, this turns to be 2 times 1, 2. 1 plus 1, the power of 4 is again 2. So 2 divided by 2 is going to be 1, right? So here is how you can find, see, the answer for this again. Okay, students, now comes question number 16. Dear students, don't forget to subscribe to this channel because it's a supportive channel, in fact. So, coming to question number 16, says if x squared y plus xy squared is equal to 2x cubed, then you are asked to find the first derivative as well as the second one, okay? So how is this done? You need to recall, dear students, the implicit differentiation, right? So using that, we can determine the answers for these two. So what you need to do is you have to introduce d by dx both sides, right? You have to introduce d by dx for the left expression and d by dx for the right one. So as you are applying d by dx for the left expression, look, you need to undergo product rule for the first one. It will be 2x times y, right? Plus x squared will be taken as it is, and when you derive y with respect to x will be dy over dx, right? So using implicit differentiation, we can obtain this. Look, this is like the derivative of x squared is 2x was actually dx over dx, which actually is 1, times y, plus, now it is what y's turn to be derivated. Take x squared as it is, and when you take the derivative of y with respect to x, you are having dy over dx. Then plus comes, this plus is directly taken from this one. Now let's derive again this expression. Again, product rule needs to be used. So the derivative of x is 1, so you have 1 times y squared, as you see, plus. Now when you derive this y squared with respect to x, 2 comes down, then 2x times y, dy over dx follows. And this is going to be equal with derivative of this one, which actually is 3 times 2, 6x squared. Now once we obtain this, let's collect dy over dx here. We are having x squared and 2xy. Now let's take this terms 2xy and y squared to the right. And then we do have dy over dx is going to be equivalent to y prime. It's y prime. This is going to be equivalent to 6x squared. Move this 2xy to the right minus 2xy. Move y squared to the right again minus y squared divided by x squared plus 2xy. You see, you're having now y prime to be like this. So your first derivative with respect to x is obtained as you see. And sometimes you may be asked to determine the slope of a tangent line to this function at a certain point. In that case, you see the values, the coordinates of the point must be substituted here to determine the slope of the tangent line at that particular point. That's all about A. And when you come to B, students, in the case of B, you are asked to find the second derivative. So as you know, the second derivative is obtained as d by dx of the first one. So here the first one requires quotient rule because it is a ratio expression. So we need to derive the numerator, and we can have this one. Look, as you are deriving 6x squared, it will be 12x. And minus is taken into account. Now consider 2xy as a single entity. So as you are deriving this with respect to x, I'm now considering 2x as a single one. 2x derivative makes 2 with respect to what, student? 2 with respect to x, and then y comes here to y plus. And as you are deriving this one with respect to x, it will be 2x y prime. It will be 2x y prime. Minus, deriving this again, 2 comes down to y prime, and then using quotient rule you will consider, take this one as it is. Look, x squared plus 2xy is taken. Then from quotient rule minus is taken into account in between, and then you will consider or take the numerator as it is. Look, it is taken here, 6x squared minus 2xy minus y squared. Now it's this expression turned to be what? Derivative with respect to x. So this is 2x, as you see it's written, and then you need to undergo product rule for this. 2y with respect to x, 2y can come plus the derivative of this one is 1 times 2x is 2x, dy over dx, which actually is 2xy prime. Then this denominator must be squared, so it's squared here. So in order to know what y second prime is, dear student, we knew what y prime is because it's already obtained here. So in place of this y prime, you see, students, in place of this y prime, where else can we obtain? Here it is, y prime. You can directly substitute this expression. In fact, it will be a certain complicated expression, but if you are interested, you can simplify it. But I'm now going to leave this for you. But it is in this way that you can find, okay, y second derivative, okay? That is the idea. Now, what comes next from this is question number 17. And in question number 17, you are given a function and you are supposed to obtain the equation of a tangent as well as a normal line here. So simple, at a certain point 0, 1. So I'm going to show you that. So the solution goes like this. First, you have to determine the slope of a tangent line. It's called that to be m, guys. So the slope of the tangent line at this point is nothing, but it is f derivative at what? At the x component, that means at 0. So f derivative at 0 must be calculated. This represents the slope of the tangent line for this function at this point, okay? So we need to determine the derivative of this function first, and that is nothing but it is 3x squared, as you see. The derivative of this is going to be 3x squared, so the slope of the tangent line at any x can be determined as 3x squared, but now specifically at 0, the slope is obtained to be 0 squared, which is 0. So if the slope is 0, clearly we know that it is a horizontal line. So y is equal to a certain fixed line is going to come. As you know, this is the equation of the line. So m is 0. So the line must pass through the point 0, 1. It has been given here. So when x is 0, y has to be 1, right? So when y is 1, look, x is 0. So when x is 0 and m is also 0, so the whole goes 0, so b turns to be 1, so y is equal to 1 is going to be the tangent line. Y equals 1 is, students, a horizontal line. So what do you expect the normal line for this tangent line? The normal line for this particular horizontal tangent line is going to be a vertical one, right? So x equals a certain, okay, a certain value is expected, right? Since, as it has been said, the normal line is, you see, normal to a tangent line, and it has to be, you see, perpendicular to that, we can take x equal to, right? X equal to expression here, and that is 0, because the point 0,1 is lying on the line. So x equals 0 is going to be the answer for this. Because x equals 0 is a perpendicular one, okay? X equals 0 is the y-axis, the vertical axis, perpendicular to y is equal to 1. Here, x equals 0 doesn't have a slope, because as we calculated before, the slope of this was obtained to be 0. Look, since the two are perpendicular to each other, the other one must be negative 1 over 0, but negative 1 over 0 is undefined. So the slope of a vertical line is undefined, right? So we need to consider x equals a certain line, but its x component, as you see here, is 0. So x equals 0, or the y-axis is the normal line, because the y-axis passes through the point 0,1 and it's normal to the tangent line, right? So the normal line is x equals 0, or the y-axis, and the tangent line is y equals 1, right? So what comes next from this is question number 18. And here, in the case of this, you are given f of x squared minus 1, x from 1 to 2, then you are asked to find the minimum as well as the maximum value for this. So you need to recall, okay, finding extreme values for, you see, absolutes, global or all global functions, okay? How are you going to obtain absolute or global extreme values for a given function, because the given interval is a closed interval? So as you know, we have to first find, you see, the critical number for this, because we don't know where these absolute extreme values may occur when you are given a closed interval. So it might occur on the critical point or number. So we need to determine that critical number, and for that, f derivative at x must be 0, right, to find the critical number. So as you are derivating this, you obtain this to be 2x, and 2x must be 0. So from this, 0 is a critical number. Yeah, 0 is in the domain, but it is not within the interval, right? If it is not within the interval, we will reject that. So we simply consider 1 in 2. So when you substitute 1 there, it will be 0, right? It will be 0, because 1 squared minus 1 is 0. And as you are substituting 2, it will be 2 squared minus 1, 3. So clearly, the minimum value is 3, and the maximum value is what? The minimum value is 0, sorry. The maximum value is going to be what? 3. These are called global or absolute extreme values, okay? Now what comes next is question number 19. Here you are asked to find the integral of these two. So just apply what we discussed before. So using using substitution technique, we can determine the integral of these expressions. So simple. So let you follow me. Now, students, for this particular case, what you need to do is let you use u to be radical x, okay? If you assign u to be radical x, the derivative of u will be 1 over 2 radical x dx. So, clearly, if you bring 2 here, 2 du can come, but 1 over radical x dx is available here. Look, 1 over radical x dx is available here. So, we can now totally write this expression of x in terms of u. Look, here it is. Cos is written as you see, but in place of radical x, u is used. And here, 1 over radical x dx is, like 1 over radical x dx is 2 times du, so 2 is written out, and the du follows. Then we know that integral of cos u is sine u, right? So this will be 2 times sine u plus any constant number, real number, okay? So finally, placing u's possible value, which is radical x, here in place of u, we do have 2 times sine radical x plus c, so it is done. So when you come to b, you see, when you come to b, again here we need to use integration by substitution, and for that to come, let you use u to be cos x, because derivative is going to come upper here in the numerator one, okay? So let u is cos x, so its derivative is negative sine x dx, and sine x dx is labeled here. So you have to adjust in such a way to determine this integral, okay? So this is going to be like this. The integral of sine x over cos squared x dx is the question we are having at hand. So this is nothing but it is 1 over u squared, because this is already u, so 1 over u squared. But sine x dx is negative du, so negative can be taken out, then integral of du follows. And we know that this is the same as u to the power of minus 2 du, just making this u squared up, 1 over u squared is the same as u to the power of minus 2. So adding 1 here, and again taking minus 2 plus 1 minus 1, minus cancels minus, then 1 over u can come along, right? 1 over u plus a certain constant c, but we knew what u is, right? U is cos x, so a matter of putting that cos x here, and we know that this 1 over cos x basically is sec x, right? So c plus sec x can come. So it is this function that makes what this the derivative of what this one that makes what the integral here, okay? So what comes next is question number 20, and here you are also given what these two integrations. One is basically indefinite integral and the other one is definite, so we are going to answer this again. So the solution for the first one can be done by just simply having u to be sine hyperbolic of x squared, the exponent here, okay? So if you let u to be sine hyperbolic of x squared, the derivative of respect to x is going to be like this. Look, you need to apply chain rule. First, you have to find the derivative of sine hyperbolic. It is cos hyperbolic of x squared. And as you are derivating the inner one, it will be 2x, right? So du will be this one times dx. Dx is forgotten here. Please add dx here, students. So du is this much times dx, right? So the integral, look, now dividing this by 2, we have x cos hyperbolic of x squared is equal to 1 over 2, what du, again dx is forgotten here, please try to add it. And from this can follow, x times cos hyperbolic of x squared is the power of sine hyperbolic x squared dx is, look, this is already u, is a part of u, because it's already u, is a part of u, and this is nothing but it is a 1 written here, 1 over 2 du, right? 1 over 2 du. So 1 over 2 is taken out as a common, as a constant now. So this integral is itself, so is a part of u over 2 plus c can come, and we know what u is, sine hyperbolic of x squared, so directly put that there. E is a power of sine hyperbolic of x squared over 2 plus c is going to be the final solution. I hope it's getting simple, right? And what comes next is b. b is a definite integral again, but remember that the integral of 1 over 1 plus x squared is tan inverse x, students, because if you remember in our class we have derived that the derivative of tan inverse x is 1 over 1 plus x squared, and integration is the reverse process of derivation. So the integral of 1 over 1 plus x squared clearly is tan inverse x. But evaluation must be done from 0 to 1, so from 0 to 1. So according to this fundamental theorem of calculus, we first put 1 here in x, and next 0 in place of x, taking minus into account, as you see. So this is going to be tan inverse of 1, pi over 4, and tan inverse of 0, 0. So pi over 4 minus 0 is going to come, and this final is pi over 4. So this integral is pi over 4. So far so good, students. Now what comes next is the workout part. So here, as I told you, there are 5 different questions. So I'm going to show you how each can be done. Again, as usual, this is a very simple tutorial, so please try to subscribe the channel. Now comes question number 1. It says the equation of, you see, 2 planes pi 1 and pi 2 are given in A and B, as you see below. In each case, you are, you see, asked to determine whether the two are parallel or intersecting in the first case. In the second case, if they are parallel, you are asked to find the distance between them, and or if they are intersecting, you are asked to find the angle between the 2 planes. Okay, so simple. What you need to do is the following. Okay, so the solution runs as you see. First, we have to know the normal vectors or the orthogonal vectors to this plane. And this orthogonal vector or the normal vector for this plane can be determined by just considering the coefficients, right? So the coefficients of, for example, in the case of plane pi 1, the coefficient of x is 1, here 2, and minus 3. So you will consider 1, 2, minus 3 as, you see, students, the normal vector, okay? The normal vector for plane pi 1. And for plane pi 2, students, you can consider the coefficients of x, y, and z again, minus 2, 4, and 6, as you see. Now, when you observe these two in A, these two vectors are parallel because one is a scalar multiple of the other. If you, for instance, multiple each component of v1 by -2, you will obtain this because -2 times 1 is -2, -2 times 2 is -4, -2 times -3 is +6. So this shows you that the two vectors are parallel. If the two vectors are parallel, what can be said about the planes? The planes are also parallel. See, students? So the planes are parallel. But in the case of B, still in question number 1, in the case of B, and question number 1 again, look here, the normal vector for plane pi 1 in B is 3, 1, 1, as you see, with a vector having component 3, 1, 1. And for this, it is a vector with 1, -4, 1, right? The normal vector for plane pi 2 in B is 1, -4, 1, right? 1, -4, 1. When you observe these two, as can be shown here, these two are neither parallel nor perpendicular, because if you just look for the dot product of the two, 3 times 1 is 3. I mean, yeah, okay, 3 times 1 is 3, and 1 times -4 is what? -4. So 3 minus 4 is -1. -1 plus 1 is 0. Sorry, students, these two vectors are perpendicular to each other. In fact, sorry. I told you that they are not orthogonal, but they are obtained to be orthogonal because if you apply dot product, it will be 0, right? But they are not parallel because one is not a scalar multiple of what? The other. One is not a scalar multiple of the other. So in the first case, they are parallel planes, but in the case of this, the second case, they are perpendicular planes because we obtained the dot product of the two normal vectors to be 0. Okay, so basically, the vectors are orthogonal. Not only the vectors in this case of B, not only the vectors, but also the planes are also orthogonal, okay? And now from this, what follows is V2 is not scalar multiple of what? V1, because of this, they are not parallel. If they are not parallel, they are intersecting planes. So the first one is answered, right? The first one is answered. The first one is already answered. Now what comes is the second one. In the case of A, if they are parallel, you are asked to find the distance between the two. So you need to use distance formula, the one we derived in the classroom. So this distance D is absolute value of, now bring this -2 to the right, you see, it will be what, 2. So you may consider this one as D1, which is 2 here. And again, 6 is already taken out, consider that as D2, D1 minus D2. You see, students, the absolute value of 2 minus 6, or D1 minus D2, or D2 minus D1 can be taken, divided by the square root of the simplified expression. The two are, you see, parallel planes. So the simplified normal vector is a vector with 1, 2, minus 3. So take the square root of 1 squared plus 2 squared plus minus 3 is a whole squared. Actually, it's positive 3, so no problem. So this is 1 and this is 4. It makes 1 student 5, and this is 9. 5 plus 9 makes 14. So radical 14, and this is 4. So 4 over radical 14 is going to come. So the distance between these two parallel planes is going to be 4 over radical 14. How about the angle between the two planes? The angle between the two planes is nothing, but it is the angle between the two what? Vectors. So the vectors are given above, so we need to determine the dot product of the two. It is obtained to be 3, 1, 1, dot with 1 minus 4, 1, and it's obtained to be 0. So no need of calculating the norm here. Actually, had this been different from 0, we would have considered cos inverse of v1 dot v2 divided by norm of v1 times norm of v2, since whatever normal value you might have in the denominator, you see the numerator is 0, the dot product comes 0. If the dot product comes 0, the angle between the two is 90 degrees, right? The angle between the two is 90 degrees, or in terms of rad, pi over 2. So having this into account, what follows is question number 2. You are asked to solve these systems of linear equations using Cramer's rule, students. It's so simple. What we need to do is we have to apply the following procedure. First, we have to determine the main determinant, and the main determinant is the determinant of the coefficients, right? The coefficient of the variables. So we have to look for that, and it is from that we can know whether this system has, you see, a finite solution, a unique solution, or you see no solution at all. So we have to look for the determinant of, you see, a matrix obtained from the coefficient of these unknowns. So the coefficients of x1 are -2, 1, 3. So here they are, -2, 1, 3. The coefficient of x2 are 1, -2, positive 1. As you see, the coefficient of x3 are 1, -1, -1. 1, -1, -2. Sorry, this is -2, yeah, -2. And so you have to determine the determinant of this. So using the first row expansion, so plus, minus, plus, so -2 is taken into account, so deleting the first column in the first row, -2 times -2 makes 4, -1, it makes +1, and then -1 is going to be taken. Now delete the first row in the second column, 1 times -2 is -2, minus 3 times -1 is negative, negative, negative makes positive, so -2 plus 3, and finally, for this one, you are having +1, and then delete the first column, the third column in the first row. You are left with this determinant. 1 times 1 is 1, plus 6 is going to come, right? So when you simplify this, you will obtain this to be -4, okay? Now the main determinant is different from 0. If this is different from 0, students, you must know that there is a unique solution, okay? But if this had been 0, you do have two options, either infinite number of solutions or no solution at all. So now coming to dx1. dx1 is a determinant obtained by, you see, omitting coefficient of x1 but writing the constants in place of the coefficients of x1 and the others as they are, okay? We know that the coefficient of x1 were -2, 1, 3. Now we're not going to use them. Instead, we are going to consider the constants here, 2, -1, 1, but the two columns, the second and third columns, are written as they are. So as usual, as you did before, use first row expansion and determine the determinant for this. 2 is going to come here, and then delete this -2, -2, 4, plus 1 is going to come. So you need to take -1 here, plus, minus, plus is considered. So -1 comes here. Now again, delete the first row and second column. This 2 makes 2, and +1 can come, right? Here it is, plus. So coming here, you see, deleting the third column in the first row, -1 plus 2 can follow, and this simplification makes 8. So dx1 is determined. Similarly, students, you need to determine dx2. In the case of this, you see, you have to change the second, the second column by 2 -1, 1. Look, here was, you see, your coefficients, so this must be changed by 2 -1, 1, but the rest are taken as they are, -2, 1, 3, 1 -1 and -2, but here in place of 1 -2, 1, we are considering the constants 2 -1, 1, and applying similar procedure as I tried to explain earlier for the above two, you will obtain this determinant to be -4, okay? And coming to dx3, as I said, now you need to change the coefficient of x3 by the constants here to -1, 1. So here the coefficient of x3 are changed by 2 -1, 1, as can be shown here, but the others are they are 2 -1, 3, 1 -2, 1. So applying first row expansion, students, applying first row expansion, this turns to be 12. Now, students, we have determined dx1, dx2, dx3. So in order to know what x1 is dx1 divided by t, and we knew dx1 is 8. It's already obtained here. This has to be divided by -4, -2 is obtained. And your x2 is dx2 divided by d, and your dx2 is -4. So -4 divided by -4 makes 1. And finally, x3 is dx3 divided by what? D, and that is 12 divided by -4, -3. Dear beloved ones, I would like to tell you one important tip here. Once you obtain these three values, you have to substitute the obtained values in your systems of equations. It must satisfy, okay? You have to assure in this way. Don't forget this, please. But I just have assured that it is true, because, for instance, if you take, for instance, the second one, it says x1, so take -2, and x2, what is that? 1. So -2, -4 can become -4 minus -3, -4 plus 3 follows, and that's -1, right? We are. Do the same again. You can check the first and the third. You will take that to be identical. So you have to assure in such a way before you finalize your answer, okay? So what comes next is question number 3. And in question number 3, you are having this sort of equation. Question A, use the definition of derivative to find f derivative at x where f of x is given. And B, you are asked to show that this is not differentiable at x equals 1. Simple. So the procedure is like this. So in the case of A, you just need to apply the definition, okay? The definition, f derivative at x is the limit of f of x plus h minus f of x over h as h approaching to 0, right? In fact, there is also another definition, but it's possible to use one of the two, so you may use this one directly. And we know that f of x is x squared plus x, and f of x plus h is going to be what, students? F of x plus h is going to be x plus h is whole squared plus x plus h minus your f of x is x squared plus x over h. What I did is I simply substituted f of x plus h in x throughout. So simplifying this, we can have this one. Just square this one, multiply this twice, and add with this, and subtract with this. You will obtain this to be this expression, 2xh plus h squared plus h over h. Matter of simplifying this, okay? Take h as a common out, so in doing so, h can be cancelled now by h, as you see. We can cancel this h by h, and finally you will have this expression. Can we use 0 now in place of h? We can. As you see, we can put 0 there, and this finally is going to be 2x plus 1. So the derivative of this function with respect to x is 2x plus 1. What comes next is b, students. In the case of b, again, you are asked to show that this is not differentiable at 1. So f derivative at x by definition is this, and you are asked now to find what f derivative at a1 is going to be. So put 1 in place of x, so this is as h approaching to 0, 1 plus h cube minus 1, because f of x is designed as absolute value of x cubed minus 1. So as you are putting x plus h here, you see 1 plus h here because x is 1. 1 plus h cubed minus 1 is going to come for, you see, the first one. And for f of x, you see, that is f of 1 because x is used by, substituted by 1. F of 1 is 1 cubed minus 1 over h can come. And from this, simplifying this, we can have the following one, okay? Which is the limit of 1 plus h cubed minus 1. This is 0, guys. This is 0. 1 minus 1 is 0, so you are having over h here, okay? And from this, what follows is, simplifying this, 1 plus h cubed, matter of multiplying this 3 times, and then deducting 1 from it, you will obtain this expression, okay? H cubed plus 3h squared plus 3h. But taking h as a common out, we are having this. Now we are having absolute value, and inside it we do have product of two expressions. So we can split this like this. We can write in terms of this one because absolute value of a times b is absolute value of a times absolute value of b, and this is this one. For h 0 from the right, you see this will be positive h, so h can be cancelled by h, then h squared plus 3h plus 3 can come. So when h 0, this automatically goes to 3, and for h approaching to 0 from the left, this will be negative h, okay? This will be negative h, so h can be cancelled by h, negative can come, so as you are putting 0 minus 3. 3 and minus 3 are different, hence the limit doesn't exist. If the limit doesn't exist, then the function is not differentiable at what? At 1. I hope you have understood it. Okay, students, now comes question number 4. It says you are given the function y equals x squared minus x squared, or asked to find the domain and the symmetry of this function, the critical point, the interval of monotonicity, okay? So in order to answer this, what you need to do is this. The domain of this function is nothing, but it is a function. It is a set that can make this defined. So you are free to take any number in place of x except those values that make this 0, right? So 1 minus x squared gets 0 when x is either 1 or minus 1, right? So the set of all real number except 1 and minus 1 is the domain of this, and the function satisfies this behavior. F of minus x is the same as f of x, okay? F of a negative number is the same as f of that, you see, positive number of the negative one. So f is symmetrical with respect to y-axis. That is to say that it is enough to sketch one part of the y-axis, okay, either the left or the right. Simply, you see, taking the image of one of the two, you can obtain the other part. So f is symmetrical with respect to the y-axis. And coming to the second one, you are asked to find the critical point, and the critical point is nothing but it is obtained, it is a point where you can have first derivative you see 0, or is a place where you can have the first derivative not defined, provided that the number is within the domain. Okay, so let's find the derivative of this one. The derivative of this can be obtained this way. You just apply quotient rule. First derivative the x squared, it will be 2x, and it will take 1 minus x squared as it is, and have minus here, take x squared as it is. Now we need to find the derivative of 1 minus x squared is minus 2x. And then the denominator must be squared, 1 minus x squared, the whole squared. So simplifying this, you will get this to be 2x, because 2x times 1 is 2x, whereas this is minus 2x cubed, right? It will be minus 2x cubed, and here also plus 2x cubed. So minus 2x cubed is cancelled by positive 2x cubed. You are left with 2x alone, 1 minus x squared, the whole square. So try to now find the value of x that makes this 0, and this is nothing but it's a critical number, as long as it is in the domain. So if the derivative at x is 0, if you see you are having this, applying crisscross multiplication, you finally obtain 2x 0. So dividing both sides by 2, x equals 0 can come. 0 divided by 2 is 0. So 0 is in the domain of the function. So 0 is a critical number, okay? So 0 is your critical number. So the critical point is the point which is obtained by taking the critical number and f at the critical number. So this is 0, and f at 0 is obtained simply putting 0 here in place of x. 0 square over 1 minus 0 square is 0. So 0, 0 is a critical point. The origin is a critical point. So up next is question number, question number 3, Roman number 3. You are asked to find the interval of monotonicity, that is to say increasing as well as a decreasing interval. And to gauge the interval of monotonicity, we do have two types of cases. One is interval of increasing, the other one interval of decreasing. The interval of increasing comes when the first derivative is positive. So the first derivative comes to be now, here it is obtained 2x over 1 minus x squared, the whole square. This is always positive, students, in its domain, because we are having square here. So though we are unable to use 1 in the minus 1, so this is always positive. So the ratio to be positive, necessarily x must be positive. That's why I'm having here x greater than 0. So when we take interval into account, so you are going to consider every value greater than 0 within the domain, but 1 is excluded because 1 is not part of what, students? 1 is not part of its domain. So the interval is going to be from 0 to 1 to union 1 to infinity. So within this interval, the graph is increasing, okay? The graph is increasing, and the graph gets decreased, or the function gets decreased when the first derivative is less than 0, and this is attained when this is less than 0. As I said earlier, the denominator is positive. For this to be negative, necessarily 2x must be less than 0, so divided by 2, x must be less than 0. So again, you are considering negative values, but the minus 1 or negative 1 has to be rejected because it's not part of the domain. So try to write now an interval excluding minus 1, and this is nothing but it is this. Minus infinity minus u1 union minus 1, 0 is the interval of decreasing. Now what comes next is question number, continuation from the question number 4. The Roman number 4, you are asked to find local extreme value, if any, and Roman number 5, behavior of concavity, and the last one is to find the inflection point for this particular slide. So in order to find the local extreme values, you see, you have to first know what the derivative of the function is. We have obtained that to be this. And clearly, as you see, you have to identify where the sign of this first derivative is going to change. Clearly, the denominator is always positive in its domain. So, but if you are using, you see, negative here, the output is going to be negative. And to the right of 0, if you are using positive value, you see the numerator is positive, the denominator is positive, you are going to have a positive output. So around the critical point 0, you are having now two sign changes on this derivative, from negative to positive, right? From negative to positive. So if at 0, at that particular number, critical number 0 is a local minimum value, because your derivative changed from negative to positive around 0. But there will never be any situation where you can have, you see, the derivative being changing from positive to negative. So we don't have local maximum in the case of this, okay? We only have local, minimum. So when we come to the discussion of concavity, which is the second derivative that needs to be involved here. So when you are carrying out the second derivative of this using quotient rule, guys, remember quotient rule. Applying quotient rule, this is going to be like this. The derivative of 2x is 2, as you see, and you will take this one as it is taken, and minus. Now 2x is taken as it is, and look, 2x is taken as it is. Now it's turns, what's turned to be derivated? It's the denominator's turn, right? So using quotient rule, 2 comes down. Look, so it's coming here. 1 minus x squared times the inner one must be derivated minus 2x. So divided by the square of this expression, so you are having now this expression being squared. Now simplifying this, what's going to come in this? What has been done here is 2 into 1 minus x squared is taken as a common out. So as you are taking 2 into 1 minus x squared, you are left with 1 minus x squared, plus here 2 into 1 minus x squared is taken out, so minus 2 times 2 is negative 4, but in here you have minus, plus comes plus 4x squared. And then look, 1 minus x squared can cancel 1 minus x squared here, so this turns to be 3 because you are having 4 here, but now this 1 minus x squared has cancelled 1 minus x squared. You are having 1 minus x squared to the power of 3, and then you don't have this expression, you are left with this expression alone together with number 2. Here it is. After simplifying this, 2 times 1 is 2, and this is minus 2x squared plus 4x squared, which makes 2x squared, and this is cubed. So clearly, as you see, this is always positive. This is always positive, so analysis is done on the denominator, right? So, as you see, the second derivative comes positive if x is within the interval minus 1 to 1. Look, it's always positive, guys. So if you are taking in different values within the interval minus 1 to 1, this turns to be positive. So clearly, the graph is concave up. Okay, concave up for this particular interval minus 1 to 1. And if the second derivative comes less than 0, if x is within the interval of what, students? Within this interval, because this gets negative if you are taking different values, you see, outside of this interval minus 1 to 1, okay? Because the numerator is always positive. If this is, you see, negative to the power of 3 is a negative number. So positive divided by negative makes negative. So within this interval it is concave down, okay? Concave down. Can we have inflection point for this? We don't have, because no value makes the second derivative 0, right? Because it is already a positive value, so we don't have inflection point for this. So having this into account, what comes next is question number what, students? Question number question number 7 of question number 4. You are asked to find, you see, the graph of this one. So everything is now obtained. The x and y intercepts are clearly at the origin, because when x is 0, y is 0, and when y is 0, x is going to be 0. So the x and y intercepts of this particular function is going to be at the origin. So the graph crosses both axes at the origin. That is a way of saying that. And we need to determine the vertical as well as the horizontal asymptote, and for that you have to look for the limit of the function as x approaching to 1 from the right. So as you are approaching to 1 from the right, you see, one approaching 1 from the right is using different values greater than 1. So as you are using different values greater than 1, it will be, okay, this will be a number greater than 1. So 1 minus a number greater than 1 will be negative, right? It's always positive. Positive divided by negative is negative infinity. Agreed? Now again here, approaching to minus 1 from the right, you see, approaching to minus 1 from the right, you are using numbers like negative 0.9. So when you square that, it will be a number less than 1. So 1 minus a number less than 1, it will be positive. So the numerator is always positive. Positive divided by positive is positive infinity. Come here again, as you are using, you see, as you are getting closer to number 1 from the left, you are using 0.9, something like that. When it is squared and 1 is deducted from it, it will be positive, okay? So positive divided by positive, positive. Same analysis can be done for these two to be negative. So you are having, you see, around 1 and minus 1, you are having either positive or negative infinity. So this shows you that x equals 1 is a vertical asymptote. But not only x equals 1, x equals minus 1 is also a vertical asymptote, okay? Even though it's not written, guys, check x equals minus 1 too. So x equals plus or minus 1 is the vertical asymptote. And as you are taking limit of this function as x going to infinity, you are having this to be minus 1, because look here, the coefficient of this is 1 and this is minus 1. 1 divided by minus 1 is minus 1, okay? So y equals minus 1 in the horizontal asymptote. That is to say, as the graph you see goes far away from the y-axis, you see it gets closer to this line, y equals minus 1. So the graph looks like as you see. You see, students, we do have a vertical asymptote at x equals -1 and x equals 1. You see, we are having plus or minus 1 here as a vertical asymptote. And here also the horizontal asymptote comes, you see, at -1. So you see, as can be shown, the graph crosses the origin, as you see. And as we said earlier, it is increasing within the given interval, decreasing with the given interval too. So anyway, the graph looks like this. What comes next is question number 5, and you are asked to evaluate this. So simple. What we need to do is we need to apply those important techniques of integration. So for the first one, it's use integration by substitution. So let you use u to be cos hyperbolic of x. Its derivative with respect to x is a sine hyperbolic of dx. X dx. So this is the question we are having. So in place of cos hyperbolic, let you use a power of 4 can come, and sine hyperbolic x dx is du. So this is use a power of 5/5 plus a certain constant c, but we knew what u is. It is cos hyperbolic of x. So finally c plus cosine hyperbolic the power of 5x over 5 can come. And when you come to b, again, let you use u to be x to the power of 4 plus 9. So du will be 4x cubed dx. So from this, 2 into 2x cubed dx can come. So dividing both sides by 2. You see what comes here is 1 over 2 du is 2x cubed dx. So the question, this is going to be now 1 over 2 times du, because 1 over 2 times du is 2x cubed dx, and here it's the power of 4 plus 9 is already u. So this is 1 over 2 ln u, ln actually absolute value of u, but not of using still absolute value because it's always positive. So this will be 1 over 2 ln of x to the power of 4 plus 9 plus c. That is the idea. And coming to c, it says the integral from 0 to pi over 2 of cos square x sine cubed x dx is basically a definite integral. So again here we need to know, we have to use integration by substitution. Let u to be cos x, students. So we can write this first sine cubed x as sine squared x times sine x. Okay, in doing so we can now, you see, change this sine squared expression to cos squared expression. Later we can use u to be cos x, so that its derivative can be minus sine x dx, right? So once we have that, look, this can be changed to this one. We know that from trigonometric identity, sine squared x is 1 minus cos squared x. We are having sine x dx here. So this integration, now we are having this. So in place of cos x, let you use u. So du will be minus sine x dx. So from this, the integration goes like this. Now look, everything of x is now changed to everything of u. So when, look here, when x is 0, cosine 0 is 1. That's why I'm having 1 here, okay? When x is pi over 2, look, when x is pi over 2, cos pi over 2 is 0. So we're having 0 here. So this minus comes because of, you see, this minus sine x dx. So this negative, because of this negative, this minus is out. Then this is u squared, 1 minus cos squared is u squared du. But from the property of this integration, we can reverse these two and have positive 0, 1, u squared 1 minus u squared du, because this is negative, we can reverse it. And this makes what? U squared minus u the power of 4 du. And we know u squared is u cubed over 3 minus u the power of 5 over 5 from 0 to 1. As you are substituting this, what you can get is 2 over 15.